Choosing the right material for your supply line makes a big difference to your overall liquid nitrogen consumption. If the line is anything more than 5 meters in length, you should seriously consider a superinsulated vacuum line, or SIVL as it is also known, to prevent excessive liquid nitrogen boil-off. Traditional foam lagging will not provide enough insulation. Is your line full of liquid nitrogen 24/7? If so, this is called a wet line and consumes 200 to 300 litres of liquid nitrogen per day just to keep the line cooled and the nitrogen liquid. A line that is only cooled on demand is called a dry line, and in most instances, a dry line is the most efficient method of using the SIVL. Keeping the line short is also a major contributor to nitrogen consumption. Typically, a dry line consumes about 1 litre of liquid nitrogen per metre of SIVL to cool the line down to cryogenic temperatures. This is because as the liquid nitrogen hits a warm pipe at -196 degrees C, it vaporizes immediately. This vaporization carries on down the line until it is at cryogenic temperature and liquid nitrogen can pass through the line. The warm gas generated by this process has to be vented away to a safe place. This is known as hot or warm gas bypass, or gas vent. The longer the SIVL, the more liquid nitrogen is required to cool it every time there is a demand for the product. So keeping your SIVL length to a minimum plays a large part in reducing your liquid nitrogen consumption. The losses for foam-lagged line is considerably higher. It is therefore important to keep the amount of times this line is cooled to a minimum. We will be discussing ways of achieving this on a later slide, but suffice to say that the more you use the line, the more liquid nitrogen you will consume. SIVL is extremely efficient at keeping nitrogen liquid, but as it uses the same principle of vacuum insulation, then you must ensure that it maintains a good vacuum to minimize nitrogen boil-off in the pipework. As the SIVL is heated and cooled, this can put more strain on the vacuum in the SIVL. As before, look for condensation or icing when the SIVL is in use. Most SIVL comes with built-in vacuum ports, so they can be re-evacuated on site if there is a loss of vacuum in the line. The liquid nitrogen pipework runs both inside and outside the building, so remember to carry out your routine checks over the full length of the line. These suggestions are for the SIVL, or super insulated vacuum line. Visual inspection. Watch out for any leaks, icing, or condensation on the SIVL during the filling process. If you see any of this, it may be a sign that it is losing vacuum and may need re-evacuating. You will get icing around the valves and non-insulated pipe during the fill process, but that is normal and nothing to worry about. How often is a line cooled? The more that you call for the liquid nitrogen, the more frequently the line is cooled, and so the more nitrogen you consume. Keeping a log of this usage will allow you to identify potential areas of improvement. Maintenance. Are all the valves in test state? The SIVL is also fitted with pressure relief valves which have to be replaced after a fixed period of time. Do you have a service agreement? When was it last serviced? And does it require re-evacuating? We have looked at some ways to make your liquid nitrogen last longer and protect your samples. What else can you look at to help you out on site? If you have a number of autofill freezers, are they linked or daisy-chained? This process, also known as one-fill, all-fill, means that you configure your freezers so that they can communicate with each other. Then, when one freezer calls for a fill, it can also send a signal to the other freezers to fill at the same time. On some freezers, you can arrange for the fills to take place sequentially or simultaneously. By doing this, you are only cooling the line down once to fill all the freezers, thus reducing the amount of nitrogen that is consumed. Also note that modern, more efficient liquid nitrogen freezers only call for a fill once or twice a week. This compares very favourably to older designs which may call for a fill once every 1 or 2 days. Does your line have a manual decant? If so, how often is that used? For example, if you are cooling 25 meters of line, which takes 25 liters of liquid nitrogen to cool, to fill a small research flask or dewar, is that really best practice? You may be better considering having a larger dewar internally which you can fill via the SIVL and then use that for filling smaller dewars. Thank you for taking the time to watch this webinar. If you have any questions relating to any of the points raised in this presentation, we will be happy to assist you. Just contact us via email or telephone using the contact details on this slide.